This video covers section 10.4, Graphing Quadratic Functions Using Transformations. Objective 5, find a quadratic function from its graph. So what we know about quadratic functions is that if you know the vertex, or I should say it the other way, if it's a times x minus h squared plus k, then you know that your vertex is the opposite of this number, h, and use that number, k. Now, judging by how wide or narrow the graph opens, that's where we're going to determine our a. So in example 8, if our vertex is at 2, 3, then I know that f of x is going to be a times x minus 2 squared plus 3. So it says h is 2 and k is 3. So we always have x minus the h, or x minus 2, and then the k value is 3, so we use that 3. Now, what is the a in this case? It's easier or easiest to find a just by finding the point that it goes through. We see that f of 0 must be negative 5. That right there is going to determine what a is. So f of 0 is a times 0 minus 2 squared plus 3, and that's supposed to equal 5. So 5 minus 3 is 2, and negative 2 squared is 4. So a second look on this, I see that that is supposed to be a negative 5. And so if I subtract 3 from both sides, that's negative 8, or gives us a equal to negative 2. So I knew this one had to be negative 2 because I saw the graph went left 1 and down 2. Left 2 and down 8. So knowing that a equals negative 2, now the function is f of x equals a times x minus 2 squared plus 3. Here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out. Then come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. So we start off with our general shifted quadratic form, x minus h squared plus k with the a in front. The vertex we see is 0, negative 7. That says that the h is 0 and the k is negative 7. So we'll put those in there, x minus 0 squared minus 7, or that just gives us a times x squared minus 7. Now we see we're at negative 2, 5, and we've gone 2 to the right down to 0, negative 7. So that's a drop of 12. It's a pretty narrow function. So we see that since it goes through 0, negative 7, f of 0 is negative 7. So I think this is pretty obvious that the vertex should not be 0, -7. It should be -2, 5. So that would give us x minus a -2. Squared, and then k would be 5. All right, that looks better now. So we have a times x plus 2 squared plus 5. And if f of 0 is -7, then f of 0 is a times 0 plus 2 squared plus 5, and that equals -7. So 2 squared is 4 times a, subtracting 5 from both sides, that's -12. So that gives us a equals -3. So then f of x is -3 times x plus 2 squared plus 5. And then the second one here, the vertex in this one is the lowest possible point. This was the highest. Since it opened down, we got an a that was negative. This a and the next one should be positive. So I've got a vertex of 2, -4. So h is 2 and k is -4. So we have f of x is a times x minus h squared plus k, which is x minus h. H is 2 plus k, so that's -4. All right, so this graph goes through either 4, 4 or 0, 4. F of 0 equals 4, so f of 0 is a times 0 minus 2 squared minus 4, and that equals 4. F of 0 equals 4, so I plugged in 0, and that output is 4. So -2 squared is 4a. Adding 4 to both sides gives us 8, or a is 2. It makes sense because we went over 2 and up 8. Normally we go over 2 and up 4. And so f of x is a times x minus h squared plus k. This concludes the video for section 10.4, graphing quadratic functions using transformations. Objective 5, find a quadratic function from its graph.